Physics Lab 3, Black Holes and Orbits. The purpose of this lab was to analyze how different masses and different resulting forces affect the motion/orbits of objects such as planets or spaceships. In this lab, we will calculate the mass of a black hole based off of the motion of a star, and then, for the second part, we will determine a ship's initial velocities that it orbits two objects without crashing. Some important physics principles for this lab is the momentum principle, or Newton's second law, and then as shown below it, you can use Newton's second law to find F net perpendicular and F net parallel, these two little equations. And then up here I have the F net perpendicular equation, and then down here I have the gravitational force equation, which we can use as shown down here to find M2, or in our case will be the mass of the black hole, the system and the surroundings. In our first part of the lab, the star is the system and the black hole is the surrounding, and for the second part, the spaceship is the system and the planet and the moon are the surroundings. So a brief overview of the result: the mass of the black hole will be 1.5 times 10 to the 9th, and then the initial speed of the spaceship, so that it orbits the planet and the moon, will be 25,000 meters per second in the x and y direction. So for the first part of the lab, I had to calculate the initial momentum vectors, and then using those, I found the change in velocity and the change in momentum. Then, I used the change in momentum to solve for F net parallel and F net perpendicular, and I used the gravitational force equation to solve for the mass of the black hole. For the second part of the lab, I calculated the gravitational force of both the moon and the planet on the spaceship, which allowed me to create position and velocity update formulas for the spaceship. After that, I tried to test the different velocities to set which would set the spaceship in orbit around the planet and the moon. For the first part, you can see right here, I created equations for the initial and final momentum, and then using these equations, I was able to create equations for the change in velocity and the change in momentum using the initial and final velocities and the initial and final momentums. And then through the next few lines, I was able to calculate the F net perpendicular and F net parallel. And then down at the bottom, you can see that I used an equation to find the mass of the black hole. And then on the right, we have the planet orbiting the black hole, and then down here we have the mass of the black hole. In part 2 of the lab, I started out by putting in the update. To begin the second part, I calculated the force on the spaceship of the planet and the moon, and then I also calculated the force on the moon by the planet and the spaceship, and that way we were able to create, down here, we were able to create velocity and position update formulas for the moon and the ship, which both moved. And then once I did that, I basically just plugged in and tested different speeds for the ship to see which one would get the ship to basically orbit the planet and the moon. And then down here you can see that this is what the code looked like when I ran it. The planet orbits the spaceship orbits the planet and the moon, and then the planet orbits, or the moon orbits the planet. So possible errors for this lab is that there might be more forces acting on the orbital objects, because there's infinitely many objects in space. So there's many more forces than what we calculated. Sorry, disregard this slide. And then also, there's no real equation to find the initial velocity. So like right here, when I was just plugging in testing, or plugging in and trying out if they worked, the initial speeds, there was no equation to find that. So I wasn't actually able to find like the perfect speeds that actually like stayed in orbit. So as you can see, kind of left orbit down here. So that's probable error. And then the difference between F net perp and par components versus the change of momentum, well, they're mathematically equal, however they are measured differently. The net force measures what is happening to the object, the momentum measures how the object responds. So the net force is kind of like, in our case, the planet and the moon acting on the ship, and then the momentum is kind of the result of that, or the change in the velocity and the mass, which doesn't change, but the velocity is impacted by the force. Also, net force is much harder to calculate because momentum is obviously just mass times velocity. And then, what if there are more celestial bodies involved? Then we would have to find the net force acting on. If we wanted to find how an object moves, we'd have to find the net force acting on that object caused by all the other different celestial bodies. This would be a lot harder, but it could be possible, and the more dominant bodies would be the ones with the larger comparative mass.